Good morning, folks. We're going to finish up chapter 3 here. Again, it's a little weird doing Wednesdays and then Mondays to finish up the content, but probably doesn't bother you quite as much as it upsets me that it's just not even Monday, Wednesday, but it's okay. After the midterm, we'll get back on to a better schedule. Don't forget our first project. It's coming up due. We had to bump them a little bit here because we weren't able to start it that Wednesday, so we do have a little bit more time on that. But I think a couple people are done already, so hopefully you've got a chance to at least get started on it. We've got a week from today. Due next Monday by the time class starts. So the first thing we're going to do in class is we're going to go over the solution to it. So make sure you've got it done. Right, I've got office hours. I did update that in the syllabus here. I think I mentioned that. We're going to meet, or I'm going to have Tuesday and Thursday from 8 to 9 in the morning, or Wednesday 2 to 5. Well, I can also chat after class as well. If you want to hang out after class, we can chat for a little while too. Right, and then we did get an updated tutoring schedule, which is awesome here. We have added Tim to our schedule, who runs the study groups for us, the group tutoring on Tuesdays and Thursdays from 1 to 2. So he's now on the list as well for Monday virtual tutoring appointments. So that's individual one-on-one tutoring, no additional charge, just a cool thing the Academic Support Center has for you folks, which I think is one of the coolest things we offer. So call or email them to schedule individual tutoring. You can go to the group tutor sessions Tuesday and Thursday from 1 to 2. And either of those, if you do an individual appointment or you go to the group tutoring session, can get you that bonus point on the weekly quizzes. Okay, let me fire up NetBeans here. Should have done that first. NetBeans is always slow. And then we'll continue on with chapter 3. We've I think we got about halfway through on Wednesday. Again, plan for another hour or so of stuff, and then the rest of the time is for you to practice. Get working on the project. Hopefully you can get that submitted without having to spend too much time outside. Almost there. Come on, NetBeans. There we go. All right, so this is I'll just keep working on this morning project here. In the Tuesday class, we'll have their projects. We'll do separate projects here in the morning. Try and keep things straight, but they'll all be in the same repository. So we got as far as our combined assignment operators, right? Let's take a look. No, and order of operations, yep. So combined assignment operator, right? This just saves us time. Remember, this is the wrong way. This one's the right way. Java's fine with either one, so just be careful when you're doing them, right? Operator first and then assignment. All right, so we talked about a couple of the different primitive types, right? The different ways of storing data. Now, the rule Java has is that anything smaller can be treated as a bigger type. That's no problem at all. So I can say, hey, I want a double for, this is some whole number, and I can assign it an integer, because integers are smaller than doubles in terms of amount of storage and amount of space, right? We're capped at 2 billion here for integers. Doubles can get a whole lot bigger because we have twice as many bytes. So this is implicit casting, saying, hey, I know you really gave me an integer, but I'm going to store it as a double, no problem. And now the number is going to be a double. You don't have to say, hey, this really is a double with 1.0. That's not necessary. Right, so mostly between integers and doubles we'll do this, but if you want with the other types, we can say, hey, some float number 1.2f, right? Add in the f to make it a float. Java's perfectly fine taking a floating point number and storing it in a double. There's plenty of room for that. And this is just the implicit casting, saying, hey, it's a smaller type, it will fit in the bigger type. So nothing wrong with that. But now we get into trouble if we do it the other way around. Right? If we say, hey, I want a float for some other float number 1.2 without the f here, we're going to get this error, possible lossy conversion. So anytime you try and go from bigger to smaller, it's going to be upset with you and say, hey, you might lose some information. So that works with doubles and floats. It works with longs and integers, or trying to store an integer in a byte or integer in a short, or any of those other types that we probably aren't going to use very much. But that all happens implicitly. If you want, you can do it explicitly. You can say, hey, really, I want you to treat this number as this type. So if I wanted to here, I could say, hey, treat this as a double. No, I'm sorry, this one's a float here, sorry, float. Treat this one as a float. So this is saying, take this number that's a double, explicitly turn it into a float. Cast it as a floating point number. So instead of having 1.2f as the literal floating point value when we compile, it says, hey, take a 1.2 double, turn it into a floating point number. This will do explicit casting. So you can cast any numeric types explicitly, you just give it the type in parentheses before the number. So if we're doing some sort of arithmetic, and I only want an integer result, right? So like an integer, I don't know, some result. I could take 4.2 divided by 3.5. It's red now because, hey, this is going to give me a double result. I can't store it as an integer. So if I really want it as an integer, I can say, hey, treat it as an int. It's still upset, though, because it's only casting the thing it touches. So remember, our order of operations here happens. So it's casting 4.2 as an integer, not the result of this. So we need to add one more set of parentheses to make sure our arithmetic happens first. Then it'll do the parentheses. That whole result then can get cast as an integer type. Then I can store it as an int. Yeah.
What about when like at the first segment where you have when you like declaring variable?
Yeah, over this side?
Yeah.
Yep.
What if you wanted to make it like a double? You have to change the first int. Like if you wanted the result to be a double.
So if we wanted this as a double, any of these numbers here are already doubles. Oops, double here, right? It's got to be, I already used some result hands. This is another result. So because they're already doubles, we're fine here. But if you wanted the result as an integer, instead of saying, hey, I want all the decimal places, we could do the casting here. So you're already going to get a double here. You're good. And we'd have the same problem if we said, hey, I want this as a float, because when Java sees these numbers, it assumes they're doubles. There's not going to be any room there. So this is the explicit casting, saying, hey, really, I really want this type, right? And it'll get rid of that error that says possible lossy conversion. So it's possible we're going to lose some information here, which we are. We're going to lose a lot of decimal places, right? 4.2 divided by 3.5, we're only going to get 1 out of it instead of 1 point whatever, right? But that's fine because we said, hey, I only want the integer result. If you want to, you can take characters and convert them as well, right? I think we looked at last time you can spell out your name. Did I do that with my name? Yeah, right, I spelled out my name here. You can do arithmetic with these because they're actually stored as numeric values. So I can take my capital E and I can add 1 to it. Oh. Come on, wake up, NetBeans. That's wrong. Right? It was 69. When we add 1, turns to 70. Well, again, okay, well, maybe I don't want the number here. What if I wanted to print out the letter? We had a couple options, right? We could either, what did we do up here? I think we did the 2-string 1 at a time, right? We printed it 1 at a time. But because we're doing arithmetic here, it's not treating it as the character value. So I can say, hey, please really treat this as a character type. Again, forcing that order of operations to happen first here, and I can get my letter back out. So I can cast those numeric values back to character after the arithmetic happens. Right? So if I wanted to, I could shift every one of my letters. So lowercase r, lowercase I, lowercase c, and then what, the first 3 were prints, right? So it doesn't go down a line. And now we get Eric done in a quick little Caesar cipher. It's not, encryption's the wrong term for it here, but the little Caesar ciphers will take your letter and like add so many numbers to it. So it'll bump it this many letters down in the alphabet. And casting here. Right, so we've done a little bit with this integer.parseInt before, where we said, hey, I'm going to ask for some input from the keyboard, and I want to convert it here, integer.parseInt. You can technically use integer to make new int values. It's not very common, but you can if you want. So I can say integer, my integer number, like this. Instead of the lowercase I int, it can be the capital integer class here. Sure, it's just not, it's not very common. You don't really gain anything doing it this way, using this type here. So you might see it somewhere, but it's not all that useful. Right, and then a built-in class, part of the Java library, which is super cool, is the math library. So if you type math with a capital M and hit dot, you should get a suggestion for all the things that Java knows how to do in math. This is part of the Java API. Abs for absolute value, arc cosine, arcsine, arctangent. Ceil is real handy, right? This will round up. So the little helper text here that it pops up if you have it pointed to the right location, it can go out to the internet to get the Java API documentation. It says returns the smallest, closest to negative infinity double value that's greater than or equal to the, oh goodness, it's barely even scrolling, equal to the argument and is equal to a mathematical integer. It's a horrible sounding definition. So if your double value is at an integer, nothing happens. If not, it rounds up to the next integer. Right, the next lowest, next smallest integer. So if you need to round up, like for project 1, where we're trying to round up the number of pies we're making, we can use math.ceil, and you can give it a number, like 4.2, and it's going to round it up. So it's not a regular round where less than 0.5 goes down, 0.5 and up goes up. Right? It will just always round up unless it's already at a whole number. So 4.0 stays the same. So 4.000000001 will round up. right? So math.ceil is handy. Another cool math function is max or min. If you give it two different values, it will give you the biggest or the smallest of those two. Just a quick little comparison there. You don't have to do like, hey, if this one is bigger than this one, print this or do something. It'll do it for you, and then it'll give you back the smallest one or the largest one. It also has the ability to do random. I typically don't use this one. There's a different way of doing random that is preferred, but you can do random here as well. So the problem with this one is it only gives you a number between 0 and less than 1, and then you have to do some multiplication and some other nonsense. So the other way of doing randoms is a little bit easier, but it's out there if you want it. Yeah, all sorts of cool things. Square root is another pretty handy one. Square root of a value. And now this wants square root of a double, right? So it's saying in this little helper text, square, you have to give it a double. We're just going to call it a right now. But remember, with implicit casting, if I give it a number that's not a double, if I give it an integer, it'll fit in a double, and Java's happy. No big deal there. Okay? But if it wants an integer and I give it a double, it's not going to fit. It's not going to work very well for us. So this math library has all sorts of cool things we can do with math. Oh, also has the Pow function. Now, math.pow. So power is to the power of. Takes A to the power of B. So anything you do in math class, we can do in Java. Right? It's not quite as good at graphing, but I'm sure we could get a graphing library. Right, so if you ever weren't sure, when we talk about like binary 2 to the whatever power, we could do say 2 to the 15th to find out what's the largest 16-bit number we could get. That sort of fun stuff. So it's 2 to the 31, right? I think it's this. That's our 4-byte numbers. All right. I guess it's not all that exciting, but just know it's out there. If we're dealing with printing numeric values out and we want to make them look pretty, either with percentages or currencies, there's a built-in way called the number formatter, which is pretty handy. So this is number format. So we say, I want to use this number format from the library, but the type of number format, we'll call it our formatter. We say equals, and now the number format has a bunch of built-in ones that we can use. So we use number format dot. Oh, we got to import it first, sorry. So we have to add the import from java.text.number format. Then we can use, hey, I want compact numbers, currency, just integers, percentages. I think percentages are kind of fun. So it'll format our number as a percentage for us. So using this formatter here, then we can go and format that particular value here. So I can output, say, I want my formatter dot format, and we have to give it, well, what percentage do we want to format? How about 0.37? So this way we don't have to, if we were taking a double like 0.37 and trying to get it to be 37%, you'd have to multiply by 100 and add a percent sign and do all sorts of fun stuff by hand. The library makes that easy for us. Right? We get 37%. So instead of having to do, right, if we had some results, maybe we could say, well, some percentage. So I could format that. Or the harder way, right, if I were just doing my own prints, I'd take that times 100, and I really want it as an integer value, right, if I want to get rid of all my decimal places, or maybe I don't want to get rid of all the decimal places, maybe I want to keep them, who knows. I could add in a percent sign. Right, trying to remember to multiply by 100 and add your percent signs is kind of annoying. So using the formatter is really handy, just as a shortcut. I got to guess the right value here. Right, and now we're still getting a 0.0 here. It looks a bit ugly. So again, the number formatter is just a little bit easier here. You can do currencies as well. And then the fun thing, it had an option. You saw when I do number format dot get, some of these ask for locales. Now, I learned other countries, I don't even remember which ones, they use a period instead of a comma to separate their digit groupings. So between 1,000 and 100, instead of like we do commas, they do periods. And then instead of a decimal place for the cents, they use a comma. Confused the crap out of me the first time I saw it. But if you give it the right locale, it can automatically do that for you. Java understands other people have other formats, which is kind of fun. But the currency formatter is fun. Right? If we want to deal with numeric output, it'll automatically give you your dollar sign. I believe it even rounds the number of cents as well, which is probably what you want to round off on pennies. I don't know how half pennies actually work. All right, awesome. It's our number formatter. They go through tons of examples with the number formatter. I don't think it's quite as interesting. If you need something larger than what a double can store with precision or size, there's actually a built-in class for it called big decimal. It stores even bigger numbers if you need even more precision. So sure, just know that it's out there. Yep, more big decimals. Those are not very fun. Hey, all right. That's the end of chapter 3. Got the big decimal. That didn't take us as long as I thought it would. Do you want to do a big decimal example?
Yeah.
Let's do it. So big decimal. Let's go add our import. Java.math.bigdecimal. So big decimals work a little bit funny in how we work with them because we don't use the operators. So here's some big number. And we'll say equals a new big decimal. And then we have to give it, well, what value do you want? Now, big decimals are nice that we can give it a string value here right off the bat. And it's going to know how to convert that here. So again, we don't need to do anything crazy large, but we could give it something really big if we wanted. I don't know, how large is that? That's only 9 billion. I think we can usually get bigger, but that's okay. That's enough for now. So I have some big number, and then let's make another one here. Another big number. How about let's just add a 1 to that. So I can't say I want a big decimal result is some big number plus another big number. It's going to be upset with us. Right? We can't use the addition operator, which is sad. Right? So when we're dealing with these classes, they're not primitive types. We can't operate on them the same way that you would expect to operate on other values. So what we can do instead, though, is we can take one number and use the dot notation. So we say, okay, some big number, dot. And we get, okay, what do you want to do here? Well, we want to add. Or I could divide, take it to the power of, subtract, right? The operations are named here. So we're doing them by name. These are called methods. Just like formatter.format. Format's the method. It's the action that we do. When we used scanner for keyboard input, we said, hey, the next line I wanted. So we can add them together with add, and then you give it in the parentheses the other big number to add. Oh, I already have a result. So this is big number result. Some big number dot add another big number. And we can just print out our big number result. I don't actually know what the value is going to be. Something large, right? 19 billion plus 9 more billion. It's 28 billion, 29 billion or so by the time it's done. Oh no. The character comma is neither a decimal digit or a decimal point. Okay, so it doesn't like my commas. My apologies. Can't add our commas. Oh, should we add some decimal places too? Can add some decimal places. Let me try that one more time. Should be smart enough to deal with commas. That's really silly. There we go. So 29 billion or so, right, with our decimal places. So just the syntax for doing the arithmetic with big decimals. We use the one value and then dot whatever we want to do with the second value. We can't use our regular operators. So we only get those operators when we deal with our primitive types. All right, awesome. Yeah, so they go through a whole, like, you can build out an invoice application if you want and do all the rounding and make things pretty. Book has some fun examples there. Awesome. I think we got it all. Let me double check here real quick. Formatting. Yeah, let's look at let me show you the better way to do random, because the math.random is kind of annoying. So if you wanted a random number, you'd have to use math.random times the value that you want. So how high of a random number should we go up to? Like if we said, let's pick a random number from 1 to any number. 23. So you'd have to multiply by 23, and then you have to add 1 to it. So this will be my int random number. So math.random will give me from 0 up to but not including 1, and then it gives it to me as a decimal place, right, or as a decimal value. So this then times 23 I want to treat as an integer. Then I want to add 1. This is kind of annoying, right, because by default it's going to give us a double. If I want it as an integer, right, it's going to lose any decimal extra part here. But because I'm getting between 0 and 1, like if I multiply 0 by 23, it's 0. Right? 0, all the decimal part goes away, and I'm going to add 1, I get 1. If I get all the way up to, but not including 1, the highest I can ever get is like 22 point something, 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 99999. The decimals go away when we turn it to an integer. 22 plus the 1 here gets me to 23. So this gets you some random values. And the problem with this math.random is we don't really have a good way to control it. So if you were to test your code and like, hey, I want to make sure I'm getting a particular value, it's going to be random every time. When we deal with the other way of using random numbers, we have a little more control over it. So the other way is there's a random class in the Java util library. So java.util.random, we can make a random number generator. So you use this random class to say, hey, I want a new instance of the random class here. And here's where you can, if you don't give it a value here, it's going to, so your computer can't actually give you random values, right? Because it will only run its algorithm. And it does the exact same sequence of steps every time, right? Just like any program, it does step A, step B, step C, on and on and on every time. So it's really considered a pseudo-random generator. Right? They look like random values because what happens when you make one of these, it takes your system clock time and uses that as what's called a seed value to say, hey, use this number in your calculations so that it looks different the next time. And every time you run your program, the clock time is different, right? The number of seconds or milliseconds on your computer is going to be different. So every time you run it, you'll get different values. But if you want, you can give it a particular value, like 10, and every time you run it, you'll get the exact same sequence of random values out because you've given it the same seed value. So it makes it a little bit easier when we're doing testing if we want to get a specific set of random values every time to make it repeatable. So then to get a different random number, this is another random value, we'd use random dot, we'd say next int, and next int you give it an upper bound. So similar to this math random, how high do we want to get? We want to do up to 23. Gives me an integer value from 0 to 22. It does not include this value. So again, we still have to do the +1, but we don't have to do any of this casting here. Okay, so maybe it takes an extra line, but then we don't have to remember to cast and force our order of operations and do all that stuff here. And this one we have a little more control over with the random instance here. Right, so next int is already giving us an integer value. We don't need any casting here. I'm much more partial to this one instead of the math random. Both will work. I guess whichever you prefer. When we start talking about dealing with random values. Right, this would make our guessing game much more interesting, right? We did our guessing game. Instead of using that magic number 42, we could pick a random number. Figure out what it is, although I don't want to have to guess 100 numbers to make this thing run. Right? We can make it a little smarter here. You want to do a random value up here? Sure. All right, let me grab this one here. Let's take this one out. I'm just going to move it up top here. So let's go from 1 to 100. So I'll say, okay, as long as it's not whatever that random value is, let me guess again. We should probably tell them too high or too low, though, right? Do we figure out if our guess was too high or too low? We say if our guess is less than another random value, we print too low. Else if the guess is greater than another random value, we print too high. Right? And there's no other case here. Because if it's not too low and it's not too high, we're only inside this loop if it doesn't equal. Right? So I don't need another case here. I don't need, oh, you must have gotten it right. Right? That happens when we're out of the loop here. So we can print, hey, you guessed it right. Like that. And then another fun thing we could do, we could even count the number of guesses that it takes if you wanted. Right? We have an int for number of guesses. Starts off at 1, right, when they guess a number. Right, and every time they guess again, we can take our number of guesses. Oops, guesses. Did I spell it? Number of guess. Nice. We could do plus equals 1, or we could do plus plus. Right, either one is fine. So if you name your variable badly, don't rename it one place and then go rename it all the other places here. Let the tool do the work for you. If you right-click on it, you can go to this refactor and rename. I can say, hey, I really wanted to call it number of guesses, add my ES and hit refactor. It's going to go find everywhere in the code and rename it for you, like a find and replace. But it'll even do it in other code files when we get to that part, which is really cool. So number of guesses. So you guessed it right. We can even tell them, right? It took you number of guesses. Right, so we can count it for them. So using this random here, now we get a little bit better a random guessing game. All right, so what number should we guess?
Try 42 again.
42? Too low. Guess again. 50? Too low. I am Wolf on Twitch. Thanks for reminding me to stand up a little straighter here. I'm really bad at hunching. 61. Too low. 80. Too low. 99. Too high. 90. Too low. 91. Hey, 91. We guessed it in 7 guesses. You folks, you need to pick the middle every time, right? That's the most efficient way, because then you eliminate half the values. Just keep cutting it in half every time. So pick 50, and then you're either too high, too low. You pick 25 or 75. You just keep going half, 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 half. All right. Awesome. So we used random here to make a little random number generator. Now the other fun thing we could do, all right, fun might be a stretch here, but that's okay. We'll say, how high of a number do you want to guess to? And we'll have an int for max number, be integer.parseInt of the keyboard.nextLine. And then we can use this max number when we generate the random value. So instead of 1 to 100, it's 1 to the max number. Right, so they can say, oh, sure, I want to guess to 10 million. Why not? Or maybe they only want to guess 1 to 10. This kept my kids busy for a good, like, 15 minutes. 15, I was impressed, like 15 minutes. I didn't think they would last more than like twice. But I've got 6 kids. They all wanted to try it, you know, a couple times. So kept them all busy. All right. So how high of a number should we guess to? Should we do like 10 million? No, it's not bad at all. Look, we guessed 5 million. Right? All right, too high. So then 2.5 million. That's too high. All right, so 1.25 million. That was too high. All right, so we go to 789,000 or something, 780,000. That was too high. All right, so we split that in half again, like 380,000. Okay, that was too low. So now we're getting close. So between 780,000 and 380,000. Let's just do 600,000. Too low. All right, 700,000. Too high. So between 600 and 700,000, 650,000. Too low, 675,000. Too low, 685,000. Why not? It's not really half, but that's close. Too low, so 695,000. Too low. All right, so we're within 5,000 now, right? That didn't take too long. So 697.50. It's too high. So 697,000. 697,000 even. Still too high. So 696,500. Too high. All right, I think we're within 500 now, right? 696,250. Too high. 696,100. Too high. All right, 696. Oh, it's still too high. Oh, I went too high. All right, so 695,500. Too high. 695. Too low. All right, we're within 500 now. We're getting closer. It's not taking us too many guesses, is it? 695. 250. Too low. 695. 375. Too low. 695. 450. Too high. 695, 400. Too low. All right, we're within 50 now. Right, we just keep cutting it down, cutting it down, cutting it down. 695, 425. Or 424, all right. 695, 415 or 410. Too high. 695, 405. 695, 402. 695, 401. 28 guesses to guess a number up to 10 million. That's not too bad, right? 28 guesses?
How many guesses did your kids have? Like a big number like that.
Oh, they took way too long.
Yeah.
It's probably like 50 or 60. Like, no, half. Not too bad, but my 13-year-old is much better at math. The 12 and 11-year-old are decent at math. The 9-year-old was just like picking random numbers out of her head. Like, how about 5? How about 6? How about 7? Hey, relax, man. Thanks for hanging out on Twitch. All right, so we're just having some fun here. It's not something I know how to do. A CSGO matching system. That does sound fun, though. All right, so we take all this code, we push it out here to GitHub. We've got it. Pick the right course here. 1500 Fall 2021. All right, so here's more Chapter 3 stuffs. All right, we're just cruising along. So we are 3 chapters in. We had the 1 day off, so this is like essentially the end of the 3rd week, right? 6 meetings or so. So I'll post the quiz for Chapter 3. I didn't post it early for you, did I? You didn't want it early, so I'm going to post the quiz for Chapter 3 today. It'll be due next Monday, 11:59 p.m. So I'll remind you again. The dates are supposed to show up in Desire to Learn too. Desire to Learn also. If you don't enter an int in any of the next line parts. So Martin, it'll just crash if it asks for a number and you don't give it one. Right? So when I ask for a number and we're trying to integer parse int, and I give it like 10, it just crashes real hard. This is the stack trace. Remember, you read them from the bottom up. So the actual failure here was at our line 67. And this is a clickable link, which is nice. It'll take you right to line 67. This is where it crashed. The actual error here at the top is a number format exception. Hey, I am Wolf. Thank you so much for throwing your Twitch Prime subscription out here. You're donating to the Student Scholarship Fund at the University of Michigan Dearborn, where I'm a student and a lecturer. So if it does crash, right, it'll tell you, start at the bottom to see what line it's crashing at. So our program here at line 67, and then this was the reason why you can't convert 10 with integer.parseInt. Doesn't work there. All right, awesome. So we got our code. We've got that pushed out here. So I'll post the quiz for chapter 3. You got a week to do that one. So the chapter 2 quiz should be due tonight, right?
Yeah.
Don't forget, they should, like, there's a little calendar thing that shows all the dates. I don't know if you ever use that calendar tool. Yeah, so chapter quiz 2 is due right next week, project 1, before class starts. So make sure you've committed it and you submit to D2L. I need both pieces. So just committing it to GitHub is good. I can see it. But until you turn it into D2L, I have no idea you want me to grade it. And that's what people usually want, is they want their points for things. Okay, so it needs both steps. And then with that assignment, don't forget to include your self-assessment, please. So look at the rubric for it and either like number the items, or I mean, this one's not so hard here, but like tell me, hey, I got the point for this, I got the point for this, I got the point for this. Later on, when things get a little bit harder, some people will settle for partial points and they'll just, that's as good as they got. Okay, that's fine. You know, I would prefer you come and ask me and I can help you finish it, but you know, if that's what it is and you're like, okay, well, I got these 3 things, I didn't get the 4th one, I got the 5th and 6th one, I didn't get the 7th one. Sure, that's fine. That's what it is. But hopefully you're planning ahead, starting them early. And if you do get stuck on something, again, spend about a good half hour to hour trying to figure it out yourself. But after that, you're just banging your head against the wall and you're going to get frustrated. You're going to get mad at yourself. You're going to get mad at me. You're going to get mad at Java. It's not good for anybody. So just reach out. Right? If you can't make the regular office hours, I do meet by appointment as well. Happy to do that if that works out any better for you. Okay, so just like for all these items here, you can just tell me, yeah, it does this, or number 1, number 2, number 3, or if you just say I got all the points, that's fine too. Ideally, you're looking at them individually. That was sort of the idea. That self-assessment would have you like, okay, yes, check. Because sometimes I lose things in translation from describing it here to putting it in the rubric. So the rubric is how I score things. So when I go up to pull it up for grading, I just click. You get all the points. All right, any other thoughts, questions, concerns? It's Monday, right? It's Monday. All right, I finally figured out I can bring my own Coke. I get it at Kroger for like 4 for $10 instead of the $2 a pop out of the machine there. But it's not cold, which is really sad. I have to find, I think there's a fridge somewhere I can use. I'll have to figure that out. But apparently my office has a microwave in it from the last prof who retired. He decided to leave his little small microwave. So. It's pretty old though. Like, I think I'll just scrap it. Because there's one in the CIS office, so I don't know why he didn't have his own. Maybe I think he liked to drink tea. Probably didn't want to have to get up and warm up his water. All right, so we'll call it a day. We got the rest of today to sit and practice. Get started on project 1 if you haven't done yet. Work through chapter 3. It does speed up. Right, we're kind of easing our way into it. This is the very first programming class probably most of you have ever had. If you've had a programming class before, you're bored. Apologize, but it will get more and more complex, and we don't get to forget any of the things we've learned in previous chapters. So it just keeps building on itself, just like math classes. Yeah.
I have a question about turning in for the project.
Okay, let me come. I'll help you in just a second. Let me shut this down.